I got it set up right
You know
here.
what, let's solidify it next week. That's for sure.
I want to start by thanking our previous mayor, DJ Lucarelli, and his committee for starting this process, and our current mayor, Waffle, for continuing and completing, well, it's not completed, for continuing it and getting it really started. I'm particularly honored that you're naming the park after me. But I also want to thank the members of Silu and Fohos, especially the Blumenthals, Janet Jackal, Karen Strickland. Oh, sorry. I'll get closer to it. I'm especially honored that you're naming the park for me. But I also want to thank the members of Silu, Fohos, and especially the Blumenthals, Janet Jackal, Karen Strickland, and Julie Roth for having the idea of a park and popularizing it. I'm indebted to Rakesh for maintaining it while he owned it and providing me access and help during that time. I'm even more indebted to Greg Wright, who has looked after the horn since I retired from Bell Labs, and in fact put it into operation for today. Now I'd like to say a bit about the history of the horn and radio astronomy at Homedale. We're all familiar with X-rays, visual light, infrared you could feel from a hot stove, microwaves, and radio. These are all electromagnetic waves of increasing wavelength. Over the history of mankind, astronomy was entirely visual until recently. Astronomy now uses all of them. In 1933, Carl Jansky announced that here in Homedale, he had received radio waves from the center of our Milky Way galaxy. This was the beginning of radio astronomy. There's a memorial east of the Bell Works building in the median of the Oval Drive where Jansky's antenna was located. In the mid-1950s, Bell Labs was thinking about using communication satellites. So when the Russians launched Sputnik, and then NASA announced their intention of putting the Echo balloon in orbit, they proposed using Echo as an experimental communication satellite. Echo was a 100-foot diameter metallized mylar balloon. Think a very large party balloon. Since a sphere reflects radio waves in all directions, the return signal would be very weak. They decided to combine two Bell Labs inventions to make a highly sensitive system, a low-noise traveling wave maser, amplifier, and this horn reflector. Unlike a conventional parabolic dish antenna, this horn reflector would pick up very little earthly radiation and not degrade the maser. In 1960, JPL bounced Eisenhower's voice off of Echo, and a receiver in this horn picked it up, and it was transmitted to the usual radio and TV feeds. The next day, there was a two-way conversation. This was the first use of a communication satellite. Later, this horn was equipped to be a backup for the first active satellite, the Telstar satellite. It had a 4 gigahertz maser amplifier put in it. Meanwhile, in 1961, Bell Labs hired Arno Penzias, who had done a radio astronomy thesis at Columbia under Charles Towns, who invented the maser, with a promise of using this horn reflector at least half of the time. In 1963, I was hired with the same promise.
We can't hear very well.
Oh, okay, I'll get, yes. There's
That's better.
Okay, I'll try to stay closer. I had done a radio astronomy thesis at Caltech, making a measurement of the bright part of the Milky Way. One might ask, why did Bell Labs hire 2 radio astronomers? I think there are 2 answers. The one they told the upper management was that we would know about large antennas, we would know about communication through the atmosphere or signals through the atmosphere, and we'd be very useful for satellite communications. I think the real reason was, though, that they had not continued Jansky's work very well. They were proud of this instrument they had built, which was very low noise, and they knew would do unique things for radio astronomy, and they wanted to see it used. About the time I came, the horn was released from the Telstar project for us to use for radio astronomy. Arno and I put together a list of projects which would make use of its unique properties. Among them was to look for the minimum brightness of the Milky Way galaxy. This might demonstrate a halo around it, but in any case, it was something we could do the horn that no one else was doing. At the Telstar frequency, extrapolation from lower frequencies led us to expect that it would not be bright enough for us to measure it. If we could successfully measure 0, something near 0, we would later shift to a lower frequency where we'd expect a small but measurable signal, and could also improve Arno's thesis. Arno had made a maser amplifier for his thesis and had considerable experience with liquid helium. He was designing a helium-cooled reference noise source to be as accurate as possible. I designed the rest of the radiometer system, including an accurate way to compare his reference source with the antenna. When we finally got it all together on May 20th, 1964, we were very disappointed to see that the noise from the antenna was significantly hotter than the liquid helium, whereas we had expected it to be cooler. We were perplexed. What was wrong with our system? Arno quipped, well, at least I made a good cold load, because any problem in it would have made it hotter and the reverse effect of what we were seeing. Ed Ohm, a longtime Homedale resident, had made the echo receiving system and had made some very careful measurement. He had noted that his system had about 3 degrees Kelvin more noise than he expected. But it was within his measurement errors, and he didn't do anything more with that other than write it in a paper. We had a direct measurement of the antenna itself and saw about the same excess. By then, Dave Hogg and I had made an accurate measurement of the gain of the horn for another project, so we didn't want to change anything until that measurement had been made. So for 9 months, we worked on the system, completed the other project, which required an accurate calibration of the system, which we were able to do in several ways consistently. And we ruled out almost everything we could think of which might explain the problem. The problem persisted unchanged. We believed in physics and knew that there had to be some source of this excess. Then one spring day in 1965, Arno called Bernie Burke. At the end of the conversation, Bernie asked, "What's going on with your crazy experiment?" They had been together some months earlier, and Bernie had asked Arno what the two of us were going to do at Bell Labs. When Arno described our Milky Way project, he had said, "You're wasting your time. There's no halo around the galaxy." So Arno described to Bernie our problem. Bernie said, "Call up Bob Dickey at Princeton." As an aside, I have said that it was a good thing that Arno worked for the phone company, because he liked to use their instrument. Also, Bernie was something like the internet of the 60s, because he made a lot of connections between researchers. Dickey was a very good physicist who had worked on microwave receivers for radar during World War II. Afterward, he became interested in gravity and invented the Brons-Dickey theory as an extension to general relativity. In thinking about where that theory might be needed, he was thinking about an oscillating Big Bang universe, where the universe expands and then has a big crunch and expands again. When it collapsed, he realized it would be very hot and therefore full of electromagnetic radiation. As the universe expanded, the radiation would cool, and by now it would be microwaves. Professor Dickey recruited 2 postdocs. He asked Jim Peebles to calculate the present temperature of what we now know as the cosmic microwave background, and Dave Wilkinson to set up a system to measure it. Jim finished his calculation first, and he had been asked to give a talk at Johns Hopkins. Postdocs don't turn this sort of thing down. He asked if he could talk about his calculations. The others agreed, saying, "We're so far ahead that no one could catch up with us." A friend of Bernie's heard the talk and told him about it not long before Arno called Bernie. Dave Wilkinson reported that they were having a bag lunch in Dickey's office discussing progress when Arno called. They heard the interesting phrase such as antenna temperature, sky brightness during the conversation. And then Dickey hung up the phone and said, "Boys, we've been scooped." A few days later, they came to see our experiment, but Bell Lab's reputation was good enough that they immediately assumed that we had done what we had said. We showed them our apparatus and they described the theory. We agreed to write 2 back-to-back papers describing cosmology and measurement. Perhaps each side thinking that, well, if the other side is wrong, we'll be right. From this simple beginning, the cosmic microwave background has grown to be our best source of information about the early universe. Dave and Jim both have had distinguished careers, Jim winning a Nobel Prize, and Dave might well have had he not succumbed to cancer. On a personal note, on May 20th, 1965, while those 2 papers were in press, 2 things happened. Arno and I were up in the cab. We received a telephone call from Walter Sullivan, the chief scientific reporter of the New York Times. He asked various questions about our measurement. Later that day, my father came for a visit from Texas. The next morning, while Betsy and I were making breakfast, he walked to the pharmacy in Homedale Village and bought a New York Times. And there on the front page of the Times was a picture of this antenna and an article describing our discovery. A happy time for father and son. I feel very lucky. I had a job at Bell Labs with very generous support and many helpful experts. I started my career when radio astronomy and cosmology were relatively new sciences, but poised to blossom as technology developed. When I entered the workforce, the nation, perhaps shocked by Sputnik and remembering the contribution of science to winning World War II, understood the value of science for its future and was willing to spend the money to be the world leader in science and technology. It's been a wonderful ride. Thank you.